Hello. In this important chapter, we are going to talk about the relationship between MATLAB and Simulink. We have talked about it before. We could use MATLAB when we wanted to enter the block information. We learned to define the parameters in MATLAB, define the code. There we could use MATLAB for assigning amounts to the Simulink. In this chapter, we are going to look at Simulink in MATLAB environment. We want to know how we can create a Simulink file by code. Also, we want to talk about Simulink outputs in MATLAB. We want to learn that how many methods are for transferring Simulink data to MATLAB and then analyze them. If you remember the multiple simulations of systems, we simulated some systems using SSTF functions and etc. Again, here I want to review that how we can use MATLAB code environment in order to enter data in Simulink. Suppose that I want to define a transform function using TF code. Its numerator is 1 and the numerator is s2 plus s plus 1. Now I can see the data of this function by TF data instruction. In order to see the numerator and the numerator coefficients, I type this amount like this. These are numerator coefficients and these are for the numerator. Now I want to simulate a system in MATLAB by these data. I add a transfer function. I enter the amounts. What I have entered in the MATLAB, I entered it to the transfer function too. I add the scope and step. You can see that there is no limitation for entering data in the Simulink. You can enter the data in the Simulink and use them later. This is one of the main advantages of the Simulink. Okay, now I'm going to explain system simulation by using codes. That how we can make a Simulink space by code. MATLAB enables user to create a Simulink model by MATLAB codes and without using blocks and modeling. In doing so, we use new system code. Now, if I go to the new system help, you can get more information about this code. When the new system defines in this way, it means that we have defined such a new system in Simulink. As you can see here, the new system means create empty Simulink system, which we can use it later. And other explanations about the system. So I define a new system here as MySys. Then we must save the system. Because it won't have external mode until saving it. We can see save system code for saving the system too. Okay, now you can see the MySys here. You can use save system code for saving the system too. Also, you can see its help and descriptions. Now I want to add blocks to my Cs. We can here at first I type the add block. You can see the add block instructions help here. For example, in this example, you can see how to use add block code. At first, we type Simulink and then the library that block located in it. Then block name. After that, we type the name of model that we want to locate block in it and block name in the subsystem. I use here add block. Without opening the Simulink library, we can use this code. I want to add a transfer function. If you remember, it wasn't continuous. I want to add it to the MySys, and I want to change the name of this block to G. Now, as you can see, the software is sensitive to name of the blocks, libraries, and even the Simulink. The names and titles should be typed correctly. Here, the continuous Simulink and etc. begin with capital letter. Pay attention that such block with this name cannot be added to MySys. I think the reason is that we have another MySys file in MATLAB. So I add another file as example 8. I use add block code. Now if I open the example, as you can see, a transfer function as h was added to my system. I clear all of these codes. I can load my system using load system code. Now I can do some other things on my system. Let me add some other blocks. One of them is step, and other one is scope. So from the sources library, I add a step. and scope from sinks library. Go to the example 8. As you can see, these 7 scopes were added to the system. If I didn't save it there, I had to use save system to save it. Okay, now I'm going to talk about adding lines to the Simulink environment by using code. I use add line to do so, add line code to do so. We go to the help to see how we can use it. As you can see in the add line code, first the name of the model which was created is used, then the block which we want to enter or exit the line, then the port number. Input ports usually are 1 and the output port is 2, then the block which we want to enter the line to it, what block it is, mux or any other blocks. Now I want to connect the signal or line form step to transfer function. Now I want to connect the signal or line from step to transfer function. First, I write the title of the model, then the block, then the block which we want to send the signal from there, which is step 1 block. I save it before as step 1 to transfer function port 1, that I save it as H. Again, I use add line to connect the second port of H block to scope block. Now I connect the second port of H block to the first port of scope, which I have saved it as scope 1. Now as you can see, the signal 1 has been made, but for the second line I face error. Again, I should use MATLAB help. I think the reason is that the system knows the ports as number 1 when I want to exit them. Because I haven't saved, you can see that it is sensitive. We lost all of the data. Again, I load the system. I use add line code again. Now, if I go to the example 8, you can see that 2 signals were added and they are connected to each other. Be careful about the saving. If your data are correct, save them. Otherwise, all the defined codes will be removed. You can use delete line code for disconnecting or removing the lines by using the name of model, its output and input, port. Okay, now I want to use sim code for simulation. This is the information of the code. Before using that code, I want to talk about parameterizing of these blocks. In doing so, we should use set param code. Here you can see how to use the code. You can use getProm to see what parameters are about your block, and you can enter them to the system. You can see the details of this code. As we can see, subsystem, import, gain, sub, and etc. All of them can be entered, and all of them are adjustable. Here you can see, based on the inter-transfer function, we have inter-numerator parameters, then the denominator parameter. Also, we can active or even inactive the absolute tolerance. We can active or even inactive continuous state attributes here. Now suppose that I want to adjust the output of transfer function. Also, I want to adjust the time parameter of step function. Okay, we talked about parameter adjustment in the model. Let me save it. Okay, now I want to simulate my system. Let me show the system again. You can see that the output amount changed. The amount of step time has changed. Usually, this way is good for those who want to work with MATLAB environment. But I suggest you to work with the block space or Simulink, because it is easy to work. You're not dealing with the codes, and you can adjust the blocks directly. For simulation and implementation of system, you can use SimOut code. You can specify stop time, zero cross, save time, or any of these options to do your simulation. For example, you can set the system to be saved after simulation. You can save the final condition of system. We can give it initial condition. We can use these options in our simulations. We can use these options in our simulations. By reading this page, you will be able to simulate your system by code. Okay, the question here is that how we can transfer data from Simulink to MATLAB by scope. As you know, data analysis and displaying them would be easier in MATLAB because of some MATLAB features. I add a scope to my new model. And signal generator. I connect them to each other. I run my system. You can see the signal here, but there are not some features in this area as saving and showing it in your papers. To solve this problem, you should transfer it to MATLAB. As I said before about parameters option in the scope block, there are some options here. For example, I go to history and now activate save data to workspace. So with this option, I can edit the figure in the MATLAB environment. You might ask, how does it work? I inactivate this option because I don't want to have any limitation. Then you have three formats. One of them is the structure with time structure and array. As you can see, I here set the structure with time. Then we have here the variable name. You can set its name. Okay. I run this system again. Now, as you can see, the R which was written earlier this year, in MATLAB menu, we have a part named plots. If you click on the plots, you can plot some of the signals that are saved array form in MATLAB. For such a structure with time signal, we must use codes. How? We can recall the time and signal exercise. Also, we can plot it in two-dimensional graph by plot instruction. You can see the signal in the MATLAB environment. Now, let's test it on array. Also, I change its name to I save it as array. Now, if you click on the K, you can see that the plot menu has been activated. You can use any of them. Let me use plot. I want to see whether the plot do the same thing or not. After choosing plot, the shape is plotted. You can save it. Then there are here different suffixes to save it. Here we use MATLAB suffixes. Here I use it with this suffix MATLAB figure. But here, in order to edit the shape, for example, I want to delete this one. As you can see, there are two signals. I can do it. I click on Show Plot Tools option, and in this window, there are editing tools. This signal is here because of the steps that Simulink consider to simulation and solving the equations. You can right click here and then delete it. As you know, here the simulation time was 10 seconds. But here the time dimension divided to 50 parts. This is because of Simulink sampling time. We should have some additions before saving it as array, but in a structure with time mode, we don't have time limitation. Let me explain you about this window. For example, suppose that here you can specify the x limitations. For example, here it is from 0 to 16, but I want to change it from 0 to 50. Also, you can have a label for this x. I want to have time which is based on second, for example, or for y axis I want to have signal label. If it was third-dimensional, we could have such things for third dimension 2. Then we go to the ticks. You can change the labels. For example, I changed the 50 to 100. After that, we go to the save as and save this shape. The R shape is like this. I want to have another shape to have comparisons between these two. Suppose that I set the amplitude 2 and frequency 0.5. Now in the scope, I want to say I will change the variable name to B. Okay, I run the system. If you go to this menu, you can see the B here too. Now the B is here too. Suppose that I want to say this K. By fig suffix. I say then the fig suffix, MATLAB fig. Then I add the B. Okay, now suppose that I want to have comparisons between these two signals. I right click on it and copy it and paste it here. As we can see, now I can comparison these two signals on a single graph. So this window enables you to edit the shapes and using them in your projects. So it is very applicative in the Simulink. I just save it and finish this chapter. Thank you for being with us. I hope you found this project effective. Goodbye.